In V2.10 you're asked to see if there's a relationship between bicep circumference in an athlete and their list test result. So what I've done here, I've entered the figures into list 1 and list 2, and then I've gone ahead and done my regression analysis. I'm going to, in this instance, copy the formula, and I'm also going to copy the residual figure into list 3. So I get 1.29 as my gradient and 0.68 to 2 decimal places as my y-intercept. Now, when you go about sketching that graph up, you'll see there's a figure there for the 34 circumference bicep athlete and a really powerful list test. This seems separate from the data. Now, in order also to find the residual plot or get the residual plot, I go to set graph, setting, and I change the y list to where I put my residuals for list 3. And then pressing the graph again, you can see that 34 point is sticking out by itself. We call that residual an outlier, and in this one instance it might pay to remove the figure and then remodel the data. Now when we go ahead and plot the scatter plots, you can see that H figure there is a little bit higher than what it should be. It really stands out quite markedly though when we look at the residuals plot. So in other words, that 0.3467 appears to be an outlier. The lift test 16.54 kilograms, greater than the equation predicts. So when it comes to considering whether the data is well modelled by the equation, we have to say no, as athlete H provides an outlier in this situation. Now, what we can do is to go back to our calculator, and we can actually delete that point at 3467. Now, we're also going to make sure that I get rid of the 67 as well. I now have to remodel that data. So let's go ahead and do that. So run it again, linear regression. I'm going to once again have the equation, and I'm going to put my residuals in list 3. So I now get 1.535 as my gradient and 2.80. So you can see the data appears evenly distributed below and above, but let's have a little look at the residuals plot. So I've got to go back to set graph, setting, and my residuals is in list 3, are in list 3. So you can see there, the data seems to be evenly distributed above the residuals line. No discernible pattern, no point out by itself. Now I'll just quickly put that graph data in for you. Take this opportunity to check it. So when we do our residual plot again, you notice I'm only having to go between +4 and -4 on the residuals. They're pretty much evenly distributed above and below the residual axis. So we can say randomly distributed residuals, no discernible pattern. And I could say an even number above and below the axis.